Hello everyone, welcome to VOLTTRON tutorial on Historian Framework. My name is Chandrika and in this tutorial I will explain the architecture and core features of VOLTTRON Historians. I will also demonstrate some of its key functions using a MySQL historian. Before we get into this tutorial, some prerequisites. This tutorial assumes that you have a basic idea of what VOLTTRON is and its overall architecture. If you're completely new to VOLTTRON, then I highly recommend that you go to voltron.readthedocs.io to get an overview of VOLTTRON before proceeding with this tutorial. Voltron.readthedocs.io is an excellent source of documentation for all things VOLTTRON. Even everything that I'm going to cover in today's tutorial is available here. So that said, let's get into our current topic, historian. So what are historians? Historians are one of VOLTTRON's core service agents that store and retrieve historical data that gets published to the message bus. Here, data can be a device data, analysis data, usage data, or user data. Historians can broadly be divided into two groups or classes. First, based on where the data gets persisted. For example, a CrateDB historian writes data to CrateDB, and an InfluxDB historian writes data to an InfluxDB data store. The second type or group of historians is based on how the data is handled before it gets stored or persisted. For example, a forward historian. A forward historian does not really persist data into any data store, but simply forwards it to another VOLTTRON instance message bus. And it's up to the agents in the destination instance to store the data as they see fit. Another example in this type is an aggregate historian. An aggregate historian computes aggregates such as average, mean, etc., and stores the aggregated data instead of the actual data received from the message bus. So these are the two broad types or groups of historians in VOLTTRON. All historians in VOLTTRON derive from a single base historian class. The base historian provides several common functionalities that are not dependent on any specific data store. It takes care of parsing and validating common configurations that the user provides. It subscribes to the configured set of topics on the message bus and handles the different data syntax associated with each of these topics. Once it parses the incoming data, it does basic validation on it, and most importantly, it caches the data to a local database before sending it to the concrete historian. Caching is an important feature that helps us recover from any unexpected failure before data is returned to the final destination. Base historian can also optionally rename topics before persisting it. This is useful when your topic name has sensitive information that you don't want to persist. For example, a building name or a device name that you don't want other agents to see. Then those can be changed to some anonymous strings, say building 1 or device 1, and these substitutions can be easily configured. Base historian also periodically checks and publishes data about the health of the system. For example, when data is getting backlogged in cache because we are not writing data fast enough to the actual data store, or when cache is over 90% of its configured size limit and we might run out of space. Base historian would detect these conditions and raise an alert. It can also send alert messages when the concrete historians fail and raise exceptions. As you can see, this is quite a list, and by supporting all these common functionalities in base historian, VOLTTRON makes it easier to implement concrete historians that can focus on just the data store specific operation or the data processing specific operations. In a given VOLTTRON instance, you can have multiple historian agents collecting data. Each agent is installed with a unique identity, a simple string value which can either be user provided or system generated. VOLTTRON platform reserves a list of identities called known identities for specific use cases. A platform historian is a historian with the known identity platform.historian. Installing a historian with this known identity enables other agents to easily access your historian's method without having to worry about what the concrete historian is. For example, A VOLTTRON central agent is an agent that needs data from a historian for monitoring VOLTTRON instances' health and for plotting topic data. The VOLTTRON central agent always calls historians' methods using the identity platform.historian and hence does not need to know what your concrete historian is. Now that we have covered what historians are and how they work, let's look at data sources and data formats historians work with. By default, historians subscribe to the following 4 topics: devices, analysis, record, and data logger. You can of course configure the historian to exclude data from any of the above 4 topics, and you can also add any custom topics for data capture. Messages from each of the 4 default topics have a specific syntax and is handled by an assigned handler in the base historian. Or in other words, these are the only formats that the historian understands or can parse. So when you add or configure new topics for data capture, data coming on these new topics should match the syntax of one of the 4 default topics. The syntax of record topics is the most flexible of all topics. This topic allows any serializable message to be published to any topic under the root topic record. The data can be an integer, a float, a string value, a JSON dictionary, essentially anything serializable. Next is the data logger. These are time point data with units and types that can be graphed easily. Here is an example data of the device point mixed air temperature. It has a set of readings associated with a timestamp. And in this data, reading and units are mandatory. Devices topic. This topic is for structured data that is scraped from devices by device drivers. VOLTTRON device drivers periodically scrape data from all the configured points of all configured devices and publish to devices topic. Data from each point is published to its own topic. For example, devices, campus 1, building 1, equipment 1, and point name. But in addition to this, VOLTTRON drivers also publish an aggregation of all point data to an all topic. For example, all data from all points in equipment 1 gets published to devices / campus 1 / building 1 / equipment 1 / all. For the sake of efficiency, historians only read all topic messages. And this is the syntax for the all topic message. It is a list that contains 2 dictionaries. The first dictionary contains point name and values as key value pairs, and the second optional dictionary contains the metadata for each of the point in the first dictionary. The last default topic is the analysis topic, and this is used for results of analysis done by applications. The format here is the same as that of the devices topic that we just saw. By now, I think you would agree with me that historians are extremely useful agents. But what if you have platform constraints or resource constraints? Can historians be tailored to your specific needs? Absolutely. Historians can be customized using configuration parameters. The base historian itself provides many useful configurations, and all of them are well documented on Read the Docs page. In addition to base historian's configuration, each concrete historian has its own list of configurations. For example, database connection parameters, data table names, authentication details to remote VOLTTRON instance, etc. Here, I have listed some of the key base historian parameters. First is history limit days. This limits how far back the historian will keep data in days. For example, you could configure your historian to keep only the last 365 days of data, and historian will automatically delete anything older than this. Next is storage limit GB. This is another way of limiting your database size. It limits the size of the data store in gigabytes. The third one is backup storage limit GB. This is similar to the last one, only that it constrains the size of the backup cache created by the base historian instead of the data store created by the concrete historian. These size limit configurations are very useful if you're running VOLTTRON on a small hardware, say a Raspberry Pi. Now the 2 configurations I want to mention today are custom topic list and read-only flag. Custom topic list is the configuration parameter you would use to customize the list of topics historian get data from. As I mentioned earlier, data published on these topics should be in a syntax that historian can parse. The last parameter is the Boolean flag read-only. Set this to true if you want your historian agent to provide only query services. That is, the historian will not collect data but allow other agents to query already existing data. So far, we have covered what historians are, how they work, and how to customize them. The next question to answer is, how can other agents in my VOLTTRON instance use the installed historian? And the answer to that is through RPC methods. Historians expose the following RPC methods for other agents to work with its data. The first one is getVersion. This returns the version of the historian code you're running. GetTopicList, getTopics by pattern, and getAggregateTopics are methods that can be used to get the list of topics in the historian's data store. While getTopicList returns a list of all the unique topics, getTopics by pattern returns only those that match a given regular expression. And getAggregateTopics returns only topics that store aggregate data. A note here, not all historians collect aggregate data, so this will return data only if the queried historian collects aggregate data. To get the metadata associated with a given topic, you can use the method getTopicsMetadata. For example, the metadata for a point topic outside air temperature could be information such as units, time zone, and data type. The next method is insert. You can use the insert method to directly insert data into the underlying data store without going through the message bus. The last method is the query method. You can use this method to query the historical data. You can query based on a single topic name or a list of topics. You can further restrict the result by providing a start and end timestamp. If you want to query aggregate data, you should also specify the type of aggregation and the length or period of aggregation. For example, to get the weekly average of a data, you set the aggregation type as average and the aggregation period as 1 week. You can also restrict the number of results returned using the count parameter. And to get results in batches, you can use a combination of count, order, and skip parameters. The order parameter can either be the string first to last or last to first. Now that you know about historians, time to see one in action. I will walk you through an example historian setup, show the data it collects, and also walk you through a test agent that queries the data. For this, I will use a VOLTTRON instance that has 3 agents. One, a master driver or a platform driver that will periodically scrape data from a fake device and publish that to the message bus. Two, a SQL historian that stores data to a MySQL database. Three, a listener agent that listens to all topics on the message bus and writes the data to voltron.log. The listener agent provides a convenient way for us to see what messages get published and make sure that the right data gets into the data store. So let's get started. Here I have 2 terminal windows connected to my Linux box. I have already cloned VOLTTRON source code and I have bootstrapped the environment. So I have all the required packages in my virtual environment. So let's go ahead and activate the environment first. And once I've activated the virtual environment, I can start VOLTTRON. This command starts VOLTTRON in the background and also logs everything to voltron.log. VOLTTRON has started successfully. So now I will use the vctl status command to check if I have any installed agents. I don't have any installed agents yet, so let's go ahead and install our test agents. First, I'm going to install the master driver agent, also known as platform driver, and the listener agent. And I'm going to do this using the VOLTTRON CFG or VOLTTRON configure command. VOLTTRON configure command is a convenience command, and it lets you install some of the most commonly used agents. VCFG requires VOLTTRON to be stopped before it can configure your instance. So let's go ahead and stop the VOLTTRON instance and run our VCFG command. You can see what agents can be installed using VCFG using the -- list agents option. It shows I can install all these agents. We are going to install the master driver and the listener. VCFG -- agent, listener, and master driver. It confirms if this is the instance you want to set up. I'm going to say yes. It's now installed the listener agent, and it's asking if my agent should auto start. I could choose yes or no. Now it's on to installing the master driver agent. I'm going to say yes to this question because we want to install the master driver agent with a fake device. Should the agent auto start? No. That's it. Now we have installed a listener agent and a master driver agent, which has been configured with a fake device so that when the master driver agent is started, it'll periodically scrape this fake device and post the messages to the message bus device topic. Now I will start VOLTTRON again. And check the status. I can see that I have two installed agents, listener and master driver. Now let's start both these agents. VCTL start zero. You can start using the identity or the agent name or a tag. Okay, I've started both the agents. Now let's check the status of the agents, if it's running fine. Okay, now this command shows both my agents are up and running and they're not in any bad state. Both of them are running fine without any errors. Now let's look at the listener agent's logs to see what data got published by the master driver agent. So let's look into our voltron.log file. And you can see here that listener agent has logged one of the messages that it saw in the message bus. The listener agent is logging the sender as platform.driver, the topic, in this case, the devices / fake campus / fake building / fake devices.all topic, and the actual message that got posted to that topic. So this data conforms to the devices data all topic syntax. So the first dictionary in the list is a set of points and the corresponding value for that point. And the next dictionary has the point and the corresponding metadata for that point. And you should see this message repeating multiple times in the log as master driver agent is periodically scraping and publishing to the message bus, and the listener is listening to this topic, grabbing these messages and logging it to the file. So based on this, we know our master driver agent is publishing correctly to the message bus. Next, let's install the MySQL historian. For this, I'm going to refer to another important documentation that VOLTTRON provides, the README files in agent's source directory. These README files provide a simple agent description, some installation notes, and dependencies, if any. It also documents all possible configuration available for an agent. This is the SQL historian's README file. It describes the historian, lists all the supported databases, in this case SQLite, MySQL, Postgres, and Redshift, and provides installation and configuration details for each of the supported database. For example, the MySQL installation notes mention about MySQL version dependencies, what kind of privileges you need to give the database user, and how to create the necessary user and tables. It also talks about the dependency, that is the MySQL connector for Python. It also lists the possible configurations that you can provide. These are essentially database connection details. You can provide these configuration either in JSON format or in YAML format. In the installation notes, you can see that it mentions a mysql.create.sql, which is a utility script that can help you set up the tables. The mysql create.sql contains all the create and grant statements needed to set up the MySQL database for the historian's use. In my test environment, I have already installed the MySQL server and MySQL client and Python MySQL connector. I have also created the database user and tables using the MySQL create.sql file. I will now log into MySQL using the database user that I created and show you the tables. MySQL -u historian. Historian is the name of the user I created. And I will use the database I created for test purpose. Test_historian is the database name. And let's show the tables. These are the tables used by the MySQL historian. Topics table store the list of topics. Data table stores the time series data. And meta table stores the metadata for each topic. Data, topics, and meta are the default table names used by the historian. But you can configure the historian to use different names, and these names get recorded in the VOLTTRON table definitions table. Now that we have taken care of all the prerequisites, we can go ahead and install our historian. First, we need to create a configuration file and provide all the MySQL database connection details in that file. For this test purpose, we will use the example configuration file that already exists in the SQL historian's source code directory. This shows the minimum number of parameters required for the MySQL historian to work. To this configuration file, you can add any of the base historian configuration parameters and customize it further. Now we'll install the SQL historian using this config file. I'm going to use the install agent.py script for this and pass the path of the source code and the path of the config file to this command. This will configure my historian and install my historian and assign a unique UUID for the agent. Now, if I do a VCTL status, it should show the newly installed agent. And now I'm going to start the agent. There. Now it says it's starting this agent. Let's go ahead and check the status again to see if our SQL historian agent is running successfully. There. This now shows the status of the SQL historian as running and the health is good. Now we will check if our historian is parsing data correctly and saving it to the database. Let's look at the topics table first. The data looks right. It has all the topics that the master driver agent published. Next, let's look at the meta table. This contains the topic ID and the associated metadata. And finally, let's look at the data table. This should contain the time series data. There. So for each timestamp, it has a topic ID and the value that got published for that topic. We know that the master driver is publishing periodically, so if all things worked well, we should see the count of data in this data table going up. Count star from data. So this number should keep going up every few seconds. There. So we can see it's continuously getting new data. So now we know that the SQL historian is running fine and recording data fine. Next, let us query the data collected by the historian. For this, I have written a simple test agent that calls the historian's RPC methods. This agent accepts two configurations. One, the identity of the historian we want to query, and two, an output file to which the results should be written. In the onStart method of this agent, I make two RPC calls. First, I call the getTopicsByPattern method, passing a regular expression to match all topics with the word outside air temperature. Next, I make a call to the query method, passing the topic, count, and order. And my topic name is fake campus / fake building / fake device / EKG. Once I get the results, I simply write it to the output file. Before I install and run this agent, I want to mention that I use the vpackage init command to create the template for this agent. The vpackage init command is a great tool to create a starting point for a new agent. The command will automatically create the agent package with an example config file, a setup file, and an agent module with sample code to publish, subscribe, make RPC calls, and much more. So if you want to create a new agent, do check out the vpackage init command. And that's the command I used for this test agent. Now let's install and run this agent to see if we can query the historian successfully. I'm going to use the install agent script again. To this, I pass the source directory, the path to the config file, and this time I'm going to also say start the agent. So this command will configure the agent, install the agent, and immediately start the agent as well. Let's check if my agent is running fine. Looks like it's running and the health is good. So let's check the output of this agent. It shows that 3 topics matched the regular expression that I gave. It prints the topic name and the topic ID. And the query method shows the time series data available for the topic EKG. And it prints the first 5 time series data available in the database along with the metadata for that topic. This brings us to the end of today's tutorial. As I mentioned earlier, all the topics I covered today are available at voltron.readthedocs.io. If you have questions regarding anything Voltron, do reach out to us at voltron@pnnl.gov or through the Voltron-community Slack channel. Thank you.